right, hush, children. I am ready to teach you.
What are we ready to learn?
Girls.
Is it unit 16, 15?
Oh, it's 15. I told you, it's all changing all the time.
There's no more units.
I believe it's day 3.
Oh, yeah, I'm kidding.
Okay, so today, guys, I need you quiet now. No more side talk. You need to be quiet. Chris, Ryan. Okay, so today we're solving exponential equations. Couple of things we need to know in order to solve. Let's write it out. In order to solve exponential equations, first thing, we need like bases. And second thing, if b is greater than 0 and b does not equal 1, if bases are equal, so are the exponents. I'll show you what I mean. So that's telling us if I have b of x is equal to b of y, and we know b does not equal 1, then we can conclude that x is equal to y. That's what that means. And if we have b of x is equal to a raised to the x, so b raised to the x equals a raised to the x, so I'm telling you this equation, well, even though I've used 2 different variables for their bases, if the equation's equal and their exponents are equal, don't their bases have to be equal? Yes. So as long as x does not equal 0, then b has to equal a. Hey, I'm going to give you some hints on how to solve exponential equations. So I'm going to say most of the time, because there's never an all the time scenario. So most of the time, it is easier to, all right, I'm going to give you a list. Convert larger base to smaller base. With fractions. No, sorry. Yeah, with fractions, convert. Actually, let me write this differently. With fractions that have a numerator of 1. Flip to write it with a negative exponent. Okay, let me show you. Are we ready?
Yes.
Give you a second. Finish writing. Oh, wow, Dylan. For the first time.
No, your handwriting is very hard to read. Yeah, I can read it now. So I can keep reading.
Okay, let's do some examples. Starting off super simple. If I have 2 to the x is equal to 8, I want us to solve for x. So what I want to do here is I'm we can do this in our heads, right? But let's pretend it was something we couldn't do in our heads. So what are we going to do? We want to create the same base. So it's easier to change the larger base into a smaller base raised to an exponent. So I'm going to have 2 to the x. I want to change 8 into 2, the base of 2, raised to some exponent. Well, what is this going to be? 2 to the third. So now that I have the same base, what do we know? X is equal to 3. All right, let's say I have 25 raised to the r power is equal to 5. Once again, we can figure this out. We can do this in our heads, but it's not always going to be something you could do in your head. So let's practice the method. So what I want to do is I want to change the larger base into a smaller base raised to a power. So I'm going to change 25 into the base of 5, but I'm going to raise it to what power to make it 25? -2. So now we have 5 to the second raised to the r equals 5 to the first. Does everybody see what I did here? I just changed 25 into 5 raised to the second power. And then this is still raised to the r. So now we have power to a power. What do you do with power to a power? Multiply. So this ends up becoming 5 to the 2r equals 5 to the first. Because my bases are the same in this equation, I can set my exponents equal to each other. So that's going to be 2r is equal to 1, so r is equal to a half. Yes?
I'm confused. Why do you have to put the r there? Like as an exponent.
Verse, where would you put it?
Isn't it just actually? No, I get it.
Because it's initially an exponent. Okay, let's do this one. So we have 16 raised to the 3x is equal to 64 raised to the x plus 1. We're going to change these both into a base of what? 4. So I'm going to have 4 to the second raised to the 3x, and then I'm going to have 4 to the third raised to the x plus 1. Power to a power, what do we do? Multiply. So I'm going to have 4 to the 6x. And now when I do a power to a power again, don't I have to distribute in that 3 to the binomial of x plus 1? So this is going to be 4 to the 3x plus 3. Now we can set our exponents equal to each other. So 6x is equal to 3x plus 3. And we are going to get x is equal to 1. Let's say I have 1/4 raised to the 2p power equals 2 raised to the p minus 7 power. So my advice to you is when you have an exponent of, when you have a numerator of 1, when you have a fraction and your numerator is 1, I would just change it so it's not a fraction anymore. So how would I change 1/4 so it's not a fraction? Wouldn't this be 4 to the negative first power? Right, 1/4 is the same as 4 to the negative first power raised to the 2p equals 2 raised to the p minus 7. So anytime our numerator is 1, I would recommend using a negative exponent so we no longer have a fraction. So now I'm going to change the 4 into a base of 2. So wouldn't this be 2 raised to the negative second power raised to the 2p power equals 2 raised to the p minus 7 power. Power to a power, we multiply, so we got 2 raised to the negative 4p equals 2 raised to the p minus 7. So now we're going to have negative 4p equals p minus 7. And then we'll have 5p equals 7, so p equals 7/5. Oh, yeah, 7/5. All right, you guys try this next one. Actually, I'll do one more with you, and then I'll have you try one.
No.
Why no?
You want to finish it? We can do it. Today's lesson is short,
Yeah,
so we'll be able to finish early.
probably.
Isn't it negative 750?
Is it -7?
No,
it's positive.
When you divide them,
Come on, man.
bro, even I know this.
Oh boy, ruthless.
You got very
Okay,
sensitive.
so guys, for this one, do you see how I'm starting off with a negative exponent? Guess what I'm going to do? Make it positive. How am I going to make this a positive exponent? By making it 8 raised to the 3x power equals 4 raised to the x plus 5 power. We're going to change these both into a base of what? 2. So we're 2 to the 3rd raised to the 3x and 2 to the 2nd raised to the x plus 5. Power to a power we multiply, so we're going to have 2 to the 9x is equal to 2. Don't forget to distribute in that 2. 2x plus 10. Since our bases are equal, we can set our exponents equal. So 9x equals 2x plus 10. So x will equal 10/7. All right, now you all try this one.
Can I do the right now?
Yep.
Uh-oh. Gotta tell me she did that. Everything else.
It's only gonna get worse, isn't it?
It's not that bad.
She says that now. She did it every time.
Really? Sure. What'd you get? Yep. Anybody want to see me do it?
No more 60.
Okay. So my advice to you, Dravid, is if there's a numerator of 1, it's a fraction, what should we do?
Like flip it.
And make a negative exponent. So here we're going to have 2 to the negative 3x power, and here we'll have 4 to the negative parentheses x plus 2 power.
Are the fractions supposed to be like all either onto the exponent, or is it just 1 over 3x all over 2?
Sorry, it should have been like that. Not just the numerator. Okay, so now I'm going to change the base. So I'm going to keep the 2 to the negative 3x, but now I'm going to change this 4 into a base of 2. So we're 2 to the 2nd raised to, I'm going to distribute in, or sorry, let's make that 2 to the negative 2nd. X plus 2. Distribute that 2 in. So we're going to have 2 raised to the negative 3x equals 2 to the negative 2x plus 4. Now we can set their exponents equal to each other. So then we're going to have negative, oh, what happened here? Oh, minus 4, thank you. Negative 1x equals negative 4, so x is equal to 4. There you go. Dravid, we good? Okay. All right, so 2 to the absolute value of x plus 2 equals 4. Don't get scared by the absolute value lines. We're going to do the same thing we always do. We're going to create our common base of 2. So we got 2 raised to the absolute value of x plus 2 equals 2 to the 2nd power. And then what do? We set our exponents equal to each other. So the absolute value of x plus 2 is equal to 2. Don't forget how to solve an absolute value equation. What am I going to do? X plus 2 equals 2, and x plus 2 equals negative 2. Subtract that 2. We're going to get x is equal to 0. That's okay. And x is equal to negative 4. It is okay to have a negative exponent. What do we not want to have? A negative base. We don't want to have a negative base. And we don't want to have a negative base when it comes to like graphing log equations, right? That's where we don't want our base to be negative. But if I give you something like this, so when we're dealing with an exponential where it's b to the x equals y, in this scenario, we don't want our base to be negative because our unknown is the variable. Do we understand? So that unknown exponent, our unknown exponent is x. So depending on what x is, it could create negative numbers. It's very different when our unknown is the base. When our unknown is the base, it can be negative because we know the exponent. But when our unknown is the base, when our unknown is the exponent, we have to make sure our base is always positive. And the reason I'm just explaining that right now is because I want to show you how this is different, this next problem I want to do. So let's say, I need a bigger eraser here. Why is it so small? All right, let's say I have x to the 2/3 equals 16. In this scenario, my unknown is not the exponent. My unknown is the base. In this scenario, is it okay to have a negative? Yeah, because what am I doing? I'm taking the cubed root ultimately of it, right? And can we take the cubed root of something negative? Yeah, because it's something times itself 3 times could be a negative. That's fine. But when our unknown is the exponent, that's when we can't have our base be negative. Does that make sense to everyone? Okay, so now in this scenario, I have x to the 2/3 equals 16. I clearly can't make them have the same base. I cannot make them have the same base. But what I can do is just solve for x by raising a power to a power. What should I do? Raise it by 3/2. But now keep in mind, when you're raising it by 3/2, that's the same, that denominator is 2, that's the same as taking what? When the denominator of the exponent's 2? The square root. And when we take the square root of something, what do we have to have? Plus or minus. No, we're going to have plus or minus. So we're going to have x is equal to plus or minus 16 raised to the 3/2 power. Now I'm going to think very strategically here. I want to change this 16 into some base raised to the second power. Why do I want to do that? Why do I want to make 16 some base raised to the second power? Okay. To cancel out the fraction. You got it. So we got plus or minus 4 raised to the second power raised to the 3/2 power. That cancels out these 2's. So now I'm left with x is equal to plus or minus 4 to the 3rd power, which is plus or minus 64. So let's just put a star here. Fractional exponent denominator is 2. Make sure answer has plus or minus.
Why is it you can't have a negative as the base?
Okay, so I had just explained when you have b to the x equals y, when your unknown is the exponent, you can never have the base be negative. Because if the unknown is the exponent, that means we can now get into like square roots, where if I have a negative base, that will then give me an imaginary number. We could get into fractional exponents. So for example, if I have, in this scenario, b equals -2, right? Then I would have an x equals 1/2. So then I would have -2 raised to the 1/2 power, which is imaginary, right? Right. So in that scenario, when we have the exponent as the unknown, our base can never be negative. But in this scenario, our exponent is not the unknown. So in this scenario, it was x raised to the 2/3 equals 16. Our unknown is not the exponent. Our unknown is the base. And ultimately, what are we doing? We're taking the cubed root of x squared, which means the cubed root of something can be negative, right? The cubed root of negative 25 is negative 5 times negative 5 times negative 5. So there's a difference between when the unknown is the exponent or when the unknown is the base. Okay, so you can't have a negative when the unknown is the exponent as your base. All right, let's keep going. All right, how about you guys try this one? X to the negative third power equals 1/8. All right, in this scenario, is our unknown the exponent or is our unknown the base? The base. Is it okay to get a negative answer when the unknown is your base? Yes. In this one, you will not get a negative answer, but I'm just pointing that out.
Wait, Mr. Alva, can you cancel out like the negative exponent?
Can you mean, yeah, of course you can.
Okay. So like, it could just be.
So you're raising it to the negative.
1. Yeah.
Yes. Mm-hmm.
That's it, right? Because you have the negative 1 here. Why should I read like a team? No, because now when I do this, I have the average and reach zero.
Would you rather Matt?
I would have Jason. That's more fun. Actually, no, that's not fair. No, you, that's fair. You. Because reach is like negative 1/3. So reach is like negative.
All right, what do we get? Who has an answer for me? Somebody? Anybody? No? Matt? I got x equals 2. Who wants to see me do it?
Because it's a cube root.
Because it's a cubed root. It's not the square root. We want to do it? Okay, let's, Shh, guys, I can't hear Claire. So the base, you mean? Yes, so when, all right, so there's two different scenarios, okay? So when we're dealing with exponential functions, all right, guys, I'm going to say this one more time. I need everybody to pay attention. When we're dealing with exponential functions, what does that mean? When we're dealing with an exponential function, b of x equals y, what is the unknown in the exponential function? B of x equals y. What is the unknown? The exponent. Exponent is the unknown. So for example, we would have like 2 to the x equals y, right? That's an example of an exponential function. So when we're dealing with exponential functions, we can never have the base be negative y. We can't have the base be negative because the exponent is unknown, which means it could be any number. So if my exponent is a half and my base is negative, that means I'm going to get an imaginary number, which is no good. But in the problems we were just doing, it wasn't an exponential function. So in this scenario, we're having x to the, 2/3 equals 16, right? In this scenario, my unknown is not the exponent. My unknown's the base. And the base can be unknown, and it could be negative, because here, when we're raising it to the 2/3, this is saying x to the second, and then taking the cubed root of that. And so if we're taking the cubed root of something, that number can be negative, right? Like negative 25 be negative 5 times negative 5 times negative 5. I mean, negative 125 would be negative 5 times negative 5 times negative 5. So our base can be negative in that scenario. So, well, it would equal something that wouldn't be making it negative. Do you see what I'm saying? So if you had x to the 1/2 equals, I don't know, 25, you're not taking the half anymore. Now you're squaring it, so it's staying positive. Does it make sense? Okay. Yes, we all understand the difference of why we can, in one scenario, have a negative base and in the other not. Hopefully, because it was the 4th time I explained it then.
Are you ever gonna need to like explain it, or can we just like?
No, you just need to know it. You just need to understand that there's 2 different scenarios. All right, who wanted me to do this one? X to the negative 3rd equals 1/8. Anybody wanted me to do that, or are we all good? Don't be shy. It's okay, Javid. I got you. Okay, so for me, I want to cancel out this exponent, so I'm raising it to the negative 1/3 power. All right, am I doing plus or minus in here? No, we only do plus or minus if this denominator is 2. So we're not doing plus or minus. So now I'm going to have x is equal to 8 to the 1/3 power. Yes? So now I'm going to change this base of 8 into something raised to the 3rd power. So I'm going to say 2 to the 3rd power raised to the 1/3. The 3's cancel, so x is equal to 2. Dravid, I went too fast?
How'd you get 8 to the 1/3?
Because this was a negative exponent. So how do I fix a negative exponent? Just flip it, right?
Oh.
To make it a positive exponent.
Uh-huh.
Yeah? For real? All right, guys, let's keep going. No, we're not done. All right, if I have 2 to the 5th power equals the quantity of x plus 3 raised to the 5th power.
Can we multiply everything?
No, we're not. Guys, so what am I telling you? The left side is equal to the right side. And aren't I using the same exponent?
Yeah.
So what does that mean? The bases must be equal. So we're going to have 2 is equal to x plus 3. Oops, no parentheses here. So x will equal negative 1. Oh, no. I got negative 1. Is that okay? Yes. All right.
See, draw it because negative 1 plus 3 equals 2.
Damn.
Right?
Hey, Tejas, you in a question too, alright? Getting this.
Dude, I got 172 for that.
Okay, guys, for number 11, for number 11, is that 2/3 belonging to the x or to the whole quantity of negative 3x? Just the x. And now I need to solve for x. How am I going to solve for x? First, I need to isolate it, don't I? So what am I going to do? Divide by negative 3. So we're going to have x to the 2/3 is equal to 4. In this scenario, is it okay if I get x to be negative? Yes. So what am I going to raise this to? The 3/2. Because I'm raising it to 3/2 and that denominator is 2, what do I have to do? Plus minus. Dravid, do you know why I'm doing plus minus?
Because of the 2.
Good. What do you think I'm going to tell you to do with the 4?
Make it
2 to the 2nd raised to the 3/2. The 2's will cancel, so we're left with x is equal to plus minus 8. You got it. All right, let's bring in log equations now.
Watch it.
What?
Watch it.
I forgot log.
We literally did it.
Wait, which one is the exponent? The exponent is what you get, right? It's the equals.
Okay, so now let's say I give you log base 8 of 32 is equal to x. I'm not going to solve this written out as a log. Guess what I'm going to advise us to do? Change it back to a exponential. Change this back to an exponential equation. So remember, it's base raised to the x equals the argument, which is 32. So base raised to the answer equals the argument. All right, I'm going to change these both into a base of 2, right? Change these both into a base of 2. So we're 2 to the 3rd raised to the x equals 2 to the 5th raised to...
6.
Oh,
To the 6. Right?
to the...
To the what?
No.
4, 8, 16, 32.
Oh, it's 5.
5, yeah.
Come on, Dylan.
Use your hand.
Why are you making me doubt myself, Dylan?
Always Dylan.
2 to the 3x equals 2 to the 5th. Now what should I do? Set them equal. So x will equal 5/3.
Are we done now?
No, 2 more.
Oh.
2 more.
And then we're done. We have optional.
Then you have homework.
Well, only optional.
Homework is easy.
No, full homework.
It's so easy. It's 5.
Odd multiple?
Wait, is it like a long sheet?
It's like 20 rows.
These are fast. These problems are fast.
Yeah, they are.
All right, somebody transfer this back into exponential for me. 27 to the x equals 1/9. Dravid, what do you think I'm going to tell you to do with that 1/9?
You know, you're gonna make it to 9 to the negative first.
9 to the negative first power.
I got it right, but
So now I'm going to change both of these to a base of what? 3. So we're going to have 3 to the 3rd raised to the x equals 3 to the 2nd raised to the negative first. So we're going to have 3 to the 3x equals 3 to the negative 3rd. And so 3x equals negative 3. So x is equal to?
Negative 2/3.
Oh, what did I do?
I don't know.
You made it 3 negative 3.
Oh, I made that a negative 3 instead of a negative 2. You guys make me flustered because all you want to do is finish.
It's Travis' fault.
Yeah, it's fine.
Is it okay for our exponent to be negative?
Yes.
Absolutely. It's okay for an exponent to be negative.
Base can't be negative, though.
Yes, in this scenario, the base couldn't have been negative. Yeah, that means you understand. Good. All right, last one. We ready?
Yeah. Is it a log?
No.
Like the hardest question.
It's not bad. If f of x equals log base 2 of x, find f of root 2.
Because x equals root 2.
So you have to set it to the 1.
You gotta substitute
So now what we're going to do is anytime we see x, what am I going to put in?
f of root 2.
F of root 2. So we're going to have log base 2 of
Root 2.
root 2.
Oh, I'm crazy.
So what am I going to do? Change this back into exponential. Even though this is an equation, that's okay. Do logs have to be written as an equation? No. So remember, it's 2 to what power gives us root 2. So what is this? X is equal to? A half. All right, we're done. Homework is a worksheet. Worksheet number 2.
Yo, today was easy, right?
14.
Today was an easy day, bro.
No, we have a big test tomorrow.
That is
I'm so sorry. Yeah. That's so